Hello everybody, this is Avantik here. Today we'll be discussing essential pandas for machine learning. The agenda is as follows. Introduction to pandas, what is it, why do you need it, understanding series and data frames, loading CSV, JSON, connecting to databases. Okay, it's pretty interesting. Descriptive statistics using pandas, accessing subsets of data, accessing rows, columns, filtering on data frames, handling missing data, dropping rows and columns, handling duplicates, function applications like map, apply, glue by, rolling, str, right? Merge, join, concatenate, pivot tables, normalizing JSON, and time series. Okay, so this is pretty much that you need for your daily work, and if you're into machine learning, you'll find this video series very useful. Okay, let's get started. First of all, an introduction to pandas. Why do we need it and all? It's a high performance, easy to use open source library for data analysis. Before we can understand what it brings to the table, okay, so this is the stage of data wrangling. After you get the data, okay, the next stage is data wrangling, that is cleaning the data, getting data, getting understanding of the data. Okay, that's typically data analysis. So you have BI, a lot of BI tools which can do this, Power BI, Cognos, right? And also Excel sheets, right? You can do that, the same thing with pandas over here. It's high performance open source library. So of course, you needn't pay anybody if you're using this, and it's pretty popular. Creates tabular format of data from different data sources, right? Be it the data is in JSON, CSV, databases, right? Whatever, Excel sheets, whatever is it, it will convert everything to a unified format. That is a tabular format. That is what you call data frames, which we'll study later. Okay, and you can do rest of the data processing on top of it. It supports database utilities like merge, join. Okay, it's fast, programmable, easy alternative to spreadsheets. Okay, and this is how you import pandas SPD. Okay, let's get to the next video, which is about understanding series and data frames. Okay, let's get started with understanding series and data frames. Series represents one column. These are like two most popular data structures in pandas. One is series, one is data frame, and series represent one column. That's what we see here. We are creating pd.series. Okay, this is the data, and this is something that a lot of people mistake here also, S is capital over here. Okay, so PD series data is 1 2 3 4 5. This is the data over here. This is the index. Index is list of ABCD. Okay, list of ABCD, it will convert this into a list where each you have A, B, C, D, E. These are like different elements. So this is a series over here. Now let's understand data frame. So we have series 1, we have series 2, and you can see the contents are different. The index is same. The important point know about data frame, which is a tabular format, and series is like column. So of course, if you combine columns, you get a table, right? So that's what we'll do now. So we'll combine this series 1 and series 2 and create a table. Okay, and that's what we are doing here. PD data frame. So this will create a table now. This is one column A, this is another column B, and series 1 is the one that we created above. Series 2 is this one, and this shows contents like this. Please make a note of one point, that the index has to be same, right? Data belonging to same row should have same index. So if there is a change in order, data frame will make sure that it will bring all the data corresponding to same index in one column. If there is nothing present for that, it will fill that with missing value, NaN. Okay, and for all your experiments and all, you might often need to create random data frames. So this is a typical example to that. So you're creating data frame from NumPy, a very useful operation. You'll use this many times, right? So np random.rand int. Okay, this is, we have seen on NumPy module 1 to 10. That means that the value this table will be between 1 to 9 inclusive, excluding 10. The size is 10 cross 10. So this is the data here, 10 cross 10 matrix of values 1 to 9. Okay, this is the index. We have 10 columns here. So this is the index value that you are giving here. This is the column names. Okay, that's what this is, the index values. This is the column name. So you can configure, create a table with index with columns, right? Okay, so this is what is series data frame, and you created series, combined series to create data frame. The important point to remember here is value corresponding to one index will be in the same row. Okay, and then we created a random number data frame. Let's go to the next topic, which is about loading CSV JSON. Let's start now with loading CSV and JSON. Okay, so say we have this data set, and you can copy the same URL. It is accessible, it's public. We have loaded this particular CSV file, and using pd.read CSV, it will convert the CSV file into data frame. And once it has converted into data frame, you can use libraries like info, okay, to get a brief idea what is there in it. So we can see this is a data frame which consists of 14,999 rows, and first two columns are float, next few columns are integer, last few columns are string. Okay, and there is no null values. As you can see, all the values are not null. Okay, so this was like reading a CSV file from a file system, or this was from the web, right? Okay, next let's go to JSON. Before we do that, now sometimes the file might be too large to load, bring entire thing in the memory, right? That's what it does. It brings entire file into memory. Okay, and sometimes it can be little too large for that. If the file consists of 40 GB or so, it is not possible to do this operation. In that situation, what you do is you configure chunk size when you are loading the data. Okay, chunk size I've configured here 5,000, right? 5,000. So what that means is it will return an iterator this time rather than a data frame. It will return a data frame iterator. Okay, HR data iterator, and you have to loop through. And every time you'll get data of 5,000 rows, right? So even if the data frame, even if the data is of size that cannot fit into your RAM, this is the way you can access all the data, get some analysis and all that. Okay, so chunk size. So this is to deal with larger data. Okay, you can see at every iteration you're doing info, you're getting the number of rows. So of course, followed by that, you can do rest of the processing. Okay, now let's get into reading JSON content. So again, we have the file over here. Of course, if the file can be in your local file system, just make sure the path is accessible, or it can be in the cloud as well. So we have the file, and in using read JSON, you are loading the data. Okay, and you can see here, it has converted the JSON content into this is the index, and this is the column. Okay, so if you really want to see the file, how does the JSON file look like? Okay, you can come here. Right, this is how the JSON file will look like. David Smith. So you can see here. Okay, you have David Smith, right? This is the index. Okay, this is the column names, right? And these are the index values. Okay, so that's all how you can load a CSV JSON. Next would be connecting to database. Let's see. Okay, let's now try to use Pandas for connecting to database. If you're using Pandas to do some data analysis on data set which consists of SQLite, this is what you'll see in Kaggle a lot. SQLite data set shared with you. Okay, so first thing you have to do is you have to install pip install PySQLite 3. Okay, this will install the driver that is required for your Python to interact with SQLite. Okay, after that you will do import SQLite 3. Then this is the file that I have in my file system, and this is one of the file that I downloaded from Kaggle dataset. Okay, so SQLite connect, and this is your file that you have downloaded. Once this is done, this is the connection details. Okay, so of course there is no username password in case of SQLite, because if the file is accessible and shared with you. Then you do pd read SQL query, and you write SQL query over here. Select star from reviews. Okay, so this is with the knowledge that this database has reviews table in it. Okay, from reviews limit 5, so it will give you first 5 rows, and followed by comma you have written the connection details, that is the connection to the SQLite. So you get what it returns you a data frame. Okay, so if you do select star from reviews, that's it, it will return you the entire data frame. So from SQLite, you actually have a data frame now. So this was an example with SQLite. In case you want to connect to MySQL, so first you have to import MySQL DB. Okay, followed by this you have to connect to the MySQL. So you have to have the right host, port, user, password, database information. You have to give all this is the connection details in that case, because your database is behind authentication. Once your connection details are there, the rest of the stuff is pretty much same. So this is how you try to connect to database, which is like MySQL, right? And the previous one is for MySQLite. Okay, let's get into some descriptive statistics using pandas. Okay, let's first load the file. This is the same file that we have loaded above as well. And when you do head, after you get the data frame, if you do data frame.head, it will give you top 5 rows. In case you do data frame.tail, it will give you bottom 5 rows. And if you give data frame.info, it will give you some information about the entire data frame. As you can see here, it is 15,000 rows that you're getting. The first 2 columns are float, next 2 columns are integer, and followed by 2 columns are strings. In this case, sales and salary, right? These are strings here. Okay, that's what we see here, right? Sales and salary, these are strings here, right? This is some information that we get. Then if you do data frame.describe, this will tell you something interesting about the numerical columns. For example, how many rows are there? Of course, everything would be same. What is the mean of the data? These are the information which is valid only for numerical data. Like this is the mean of satisfaction level. This is the mean of last evaluation. This is the mean of number of project, right? You get to see here standard deviation, minimum 25%. What is the data? 25%, 50%, 75%, the max of it, right? You get to see all this numerical information, but to be precise, it shows only about numerical data. You want to see what is the distribution of categorical data, you can use things like the column, categorical column that you're interested in, and followed by value counts. It gives you the distribution of categorical data. You can see here, this is the number of people with low salary, this is the number of people with medium salary, and this is the number of people with high salary. So for all categorical data, you can use this to understand the distribution of it. So we'll use pandas now to access subset of data, rows, columns, and filters. Okay, let's see. So first is many times you have a data frame which has like hundreds of columns, right? And you want to find out, okay, what are the numerical columns or what are the columns with strings, right? Very common operation. So you have a useful utility, select D types. And if you mention your object, it will return you a data frame which consists of, which the type of it is object. So it returns you sales and salary. You can put here integer 64, it will return you the columns which is of integer 64. So very useful. The another operation that you might have to do very often, like in this case, this column name is wrong actually. It should be department and it is wrongly written sales here, right? You want to rename this column. So data frame dot rename, and you have to mention here columns. Sales you want to rename to department, and in place is equal to true. When you mention in place is equal to true, the current data frame will undergo the changes. Otherwise, it will return a new data frame with the changes that you are mentioning. Okay, when you mention in place is equal to true, the current data frame will undergo the change. Okay, and as you can see here, after we are done with this, the current data frame dot head, you can see that the column name is correctly changed into department. Now we'll understand how to select couple of columns from the data. Say if you do data frame dot columns, it will return you all the column names. And if there are 3 columns that is of interest, you have to pass that in double braces, right? It will return you a data frame. This will not work if you put single bracket over here. So these are the columns of your interest. You're putting the 3 columns, and what you get in return is a data frame with this 3 column. So another way to get this data is HR data dot satisfaction level. This is fine if the column name does not have spaces in it or some special character, uh, like dot in it. Okay. So this is how you can access a column. Okay. But remember, it will return you a series. If you want to still get a data frame of 1 column, you have to put it in double braces. Okay. See, single braces is returning a series. Okay, if you want a data frame, put that double brace over it, double bracket over here. Okay, so loading in the JSON data again, because we need a data frame which looks like this. Okay, now what we want to do, we want to understand accessing by rows. That was typically, the previous one was typically accessing by columns. Let's now try to understand accessing by rows. So you have a utility lock. Okay, and with lock, you are passing here the column name. Okay, so lock, and this is the row index, right? Okay, this is the row index Scarface that you see here. It will return you a series which consists of the value in here. Okay, so lock. So lock will expect index values. These are index values here. Okay, you can mention range here, Scarface and Vertigo. So it will include Scarface and Vertigo and all the data in middle of it. So you can see the data over here, lock. Okay, so since if you can, this can be implicitly called. If you directly pass it, it will be implicitly calling this lock function. So this will also work, but this is what implicitly gets invoked. Then you have another utility, ilock. Ilock is by accessing by index number. So when you give data frame dot ilock1, you are telling I need first row, and this is what you get there. Okay, you can access ilock in range also, but in this case it will return you only row 1, 2 and 3, not 4. Okay, so the difference, fundamental difference between lock and ilock is lock will take index values, ilock will be index numbers, right? That's the only difference. Let's understand how filtering happens. So you want you want a data frame which matches certain criteria. Okay, so let's see this. We have this data frame over here, movie data, and this is the data frame, and this is the filtering criteria. You can see this is the column name and this is the condition. So if you use this data, it will return you, if you use this, it will return you a Boolean array. Okay, and there will be few rows which will be true, and when you pass that to the data frame, it will return only the rows for which it was true. Okay, so this is the filtering. If you want to combine different filters, you can do that with and make sure you pack it up with braces over here to make it clear. Okay, so this was about accessing rows, columns, and filtering the data frame. Okay, let's get into the next topic, which is about handling missing data. Let's get into how to deal with missing data. Machine learning do not expect data to be missing. So you have to take care of that. And in real situation, there will always be data which is missing. So there are certain techniques. As we learn throughout the course, we learn more and more stuff around it. But using pandas, we learn how to deal with that. There's some certain thumb rules around it. If there is a column which is more than 40% data missing, then you can say you can drop the column, because filling half of the data does not make a lot of sense. There is a row which consists of a lot of important column missing in it, you can drop that rows itself. Okay, so they're like thumb rules, but if this does not fall under this two category, we'll see what has to be done. Consider the data, the movie data that we have been using so far, and this is how it looks like. Right. First, you need to identify whether there is missing data in it or not. Like say, build a fee is the column that we're interested in. Okay, so movie build a fee not null. So it will return you, a Boolean array which will be typically telling you which row will be present. So if you pass this Boolean array in the movie data, it will return all the rows for which build a fee was not null. Okay, build a fee is not null. And in case you want to get all the rows in which build a fee was null, kind of the reverse, you will use the function is null, right? This will return a Boolean array, and whichever is true will be returned when you pass this way. So you can see build a fee, right? Is null was returning true for only these rows. So now we have a data frame which looks like this. Okay, so now let's understand how to drop rows and columns. So let's now drop rows and columns and deal around it. So we have this data frame here which we're loading. This is Titanic data. Okay, everybody must be aware of the Titanic ship which sank in 1904. A very popular movie was based on that. So this is the data set. So this is how it looks. So as you can see in the data, there are some columns which is null values like this: age. Okay, age has the total number of rows is 891, and you can see only 714 has data in it. So there is like good amount of 140, 160, 170 data which is missing out here. And you can see this column cabin, which is only 204 data present out of this 891, only 25% of 25% of the data present. So essentially we can say dropping Kevin column would make a lot of sense. So to drop a column, this is what you can do: drop, and in the list you can mention the column names that you are interested in dropping. XS1 means all, drop all the rows for this particular column, and in place is equal to true, so that the data frame undergoes change. So because of this function, this code, what we see over here, you don't have the cabin column anymore. Okay, so now in case you want to, I mean, this is how you are getting to deal with the rows which has missing values in it. Now suppose after this first level of dropping, you want to drop all the rows in which any value is missing. So that is what drop any function will do. It will drop all the rows in which any value is missing. So on calling this function drop any, see the number of, so now after this we'll see the data frame now consists of all the rows which has all the values present in it. Okay, and please have a note here, I'm not passing in place is equal to true, so my data frame is not altered. Okay, so that's the reason my next function, if I do info, I still get the same data frame. Had I entered in place is equal to true, this data frame, this won't be the output, it would be the same here. Now, many times you do not want to consider few columns when taking a decision whether to drop it or not. Okay, you want to take only important columns into consideration. Say you want to drop it based on embarked and age. Okay, so that's what you're seeing here. So it is not taking into consideration any other column but embarked and age. If there is a missing value in one of these columns, then only it will be dropped. Again, there is no in place is equal to true, so I still get the same data frame. Okay, now if you have the missing values, you might come with different strategies to fill the missing values, right? One of them is using fill NA. Okay, in fill NA, you can pass the column names. Say age, you are replacing by 0 in this case. What you can do possibly is find the median of the age and can replace over here. Embarked, or by default, you can assume that people for whom there is no details, you can assume that they were not there in the ship. Okay, so of course you can mention unknown over here, or you can mention not present in the ship. Okay, so this is one of the filling technique. Then for a specific column like age, you want to fill it by whatever, if a value is missing in a particular row, you want to fill it with the previous value that is present. This might not be suited very well for age, but for like temperature, right, for rainfall, so this kind can works out pretty well. So you have two technique, one is F fill, one is B fill. B fill is back foot fill, F fill is forward fill. Okay, so that's how you deal with you drop rows, columns in case of missing values, you fill values over here. Okay, now let's get in the next topic, which is like understanding duplicates in your data sets. Let's now get into handling duplicates. Imagine a situation where you have a central repository and it is getting data from different stores which is spread across different cities, right? So possibilities of data getting duplicated is pretty high. And you need to make sure you don't send duplicated data to your data analysis team, else whatever analysis is coming out might not be that reliable. Okay, so consider a data frame which looks like this: A, B, and C. This is the data, and this is how it looks like. And you can see here first row and fifth row is same. So if you use df.duplicated, it will return true for the rows which is kind of duplicate. So you can see this fifth row is true because it is duplicated with here. Okay. Now if you do df and df.duplicated, okay, and this is okay, it's returning a duplicate data. Now if you have an argument of subset, what subset does it tells you not considering all the columns, because timestamp can be different but the other data can be duplicated. So this allows you to do so. So if you mention A and B, it is telling you that these are the, it's repeated twice, as you can see here. Okay, if you don't consider C, A and B is repeated twice, right? You have 3 times this, right? So first and fifth will be returned over here, as you can see here, right? This is how you deal with duplicates. Let's, after this, it'd be an interesting topic of function application. Let's see that. Let's get into function application. We learn here map, apply, rolling by, string, str. Okay, that's one of the most important topic in pandas and gives you a lot of flexibility to do a lot of wonderful things. Let's see what it is. Let's first start with map, which has the ability to transform one column into another. Consider the Titanic data set that we have. So we have the age column here, right? So what we want to do is based on the age, like if it is less than 18, you want to have a kid. If it is greater than 18, you want to have a value corresponding to adult, right? That's, you want to convert this age into categorical data. That's what you want. Okay. So first thing, I mean, here Titanic data dot age map. Okay, and this is the function that will be executed. You can write a separate function for that. Also, you can place a lambda over here. So you can see if age less than 18, it is returning kid, else it is adult. Okay, and that is what it returns. If you see these are all the adults and it's converting it to adult. So this is the first function, apply, sorry, map. Okay, and you can remember this is like, this will only deal with one column. Okay, if you want to deal with multiple columns, then you have apply, which you'll see in a while. So the same behavior can be achieved by apply as well. So rather, map is an implementation internally implemented using apply. So you have Titanic data age apply and the similar stuff over here. Okay, so it will return you a new column over here, which you can of course overwrite. Okay, and if you simply pass an aggregation function like sum here, it will sum all the age. Right. So now let's see how can we now deal with multiple columns using apply. Okay, let's take an interesting case here. For example, you have the data frame, and if it is male, okay, you want to multiply fair by 2 times. Being a male, I don't want it to happen. Okay, if it's female, you want to retain the same fair. Okay, sort of this static. So you need to have multiple, more than one column into decision making now. Okay, and you want the value, whatever operation you do it here, you want to return as a new column or say. Okay, so data frame dot apply, this is the function. Okay, this function gets some parameter e. Okay, so this will be internally invoked by pandas, and e will be each row at a time, each row. Okay, since you're passing x is 1. Okay, if you pass x is 0, it will be column, so each column, so it will apply function, and you can mention here this will be each column at a time. So now by default your kid's getting all the rows. Okay, so this is one, sex is one column, fair is another column. You get access to both of them, and after accessing both of them, you're returning the new values over here. Okay, so if you mention x is 0, you'll get columns. Since you're mentioning x is 1, you're getting rows here. Okay, keep that in mind. Okay, let's now understand group by. It's very similar to what is present in databases. Okay, Titanic data dot group by, and you're grouping by sex, and you're calculating mean of age. So that is what giving is females average age is 27, male average age is 30. The more generic implementation of is group by, and this is the column that you're interested in, and this is the aggregation function. And after, okay, and what you're trying to do is you're trying to get mean, min, max, right? And this is what is for female, mean age is 27, minimum is 0.75, maximum is 63, male is 30, 0.42 and 80. Okay. Next is rolling operation. So you have Titanic data, age, and rolling. This is like windowing. It's a sliding window. So the window size is 5. Okay, and minimum periods is 1. So first time you have 1 value. Second time it is 2. The third time it is 3. So okay, if you don't mention the minimum periods, it will have 1 value first time, and rest of the stuff is not a number, like not missing values. So the value that it will predict here will be NA. So to take care of that, you have mentioned minimum periods, right? The number of minimum periods by the max it considers is 5, minimum it allows it is 1. And you're for that moving window, you're calculating sum and min, right? So sum of 5 rows of age is 22. Okay, first day was 22. First and second was 60. Then first, second, third was 86. First, second, third, fourth was 121, 156. right? This was first 5. Then it moved here, the window. That is where this is coming this way, right? And as you can see here, the this was the minimum value, right? Of course, we can add more aggregation things over here, but this is how the rolling things. It's like moving window. It's very useful when you want to understand the trend, right? You can see the mean is going up, so it's very useful in time series where stock data, okay, weather reports and all that. Now let's see the string part of it. Okay, many times your column consists of string data. Like in this case, you have a name column over here. You want to fetch all the rows which consists the word Mr. in it. That's also name.str. And followed by that, you'll have a lot of functions. If you put a dot and tab over here, you'll see a lot of functions. Most of them are string functions. Like it will have uh, functions like contains is what you are seeing here. It will have starts with, ends with, all the string functions are present here. So contains Mr. This will return you true or false, which you're passing to the data frame, and you're getting all the data frame, all the rows for which there is a MR present in the name. Okay, that's all from function application part. Okay, let's now try to understand database style, append, merge, join, concatenate operations. Let's now understand append, merge, join, and concatenate. Pretty much combining data and very useful in real world scenarios. And this is most of a database style and pretty fast. Okay, let's see one by one. So we have two data frame here, df1 and df2. As you can see, we are generating 10 rows, 3 columns, both the data frame, df1 and df2. Okay, let's now try to append it. Okay, append it, in this case it's like stacking on top of one another, and you're doing ignore index thing here, so which is making sure the index is regenerated over here, right? Otherwise it will be same index getting repeated. Okay, now let's see a data frame which is 3 columns like key A and B, and key C and D. Now what we want to do, we want to merge based on the key column. Okay, so left dot merge, this is the first column, first data frame, merge right data frame on, this is the by default. Even if you don't mention key over here, it will find the common column name and try to do that on that. But for the best, safer results, you better mention column name over here. So the key column, that is what you are interested. Sometimes uh, you might not have same column name. For that, you will use parameter like left on, right on, right? You have those utilities over here. Okay, and you have different type of joins or merge that is possible over here. You have how late this is left merge. Okay, so left merge. You can do right merge. By default, it is inner join. And sometimes you want to do join based on the index values. So as you can see, this is the index values K0, K1, and K2, K0, K2, and K3. You want to join based on that. So left join right. As you can see here, K0 and K2 is common. So okay, K0, K2 is common, and K1 is not present over here, right? Okay, K1 is not present in this guy. So that is why these values are NN over here. So you have append, merge, and join. These are the 3 utilities by which you can combine data frames. Okay. Let's understand pivot tables. A very useful way to gather important information from the data. If you're a data scientist, this is one thing that you'll use very often. Okay, and it makes your understanding of the data very simple. Let's see. So this is the data that we have now. Okay, and you can see here, this is the account details, this is the name, this is the name of the company, this is the representative, this is the manager, this is the product, quantity, price, and status. Okay, this is how the data looks like now. Okay, so now we want to do a pivot table. Okay, so pivot table, you basically want manager, representative, and amount of sales and all. Okay, so PD pivot table, this is the data frame that is into consideration. Index will be your manager. Okay, and each manager will have multiple representatives under him, right, or her. So you can see there are 3 representatives under Deborah and 2 representatives under Fred, right? And what are the operations you are doing? We are considering amount, account, and price. account and price, and you're finding sum of account number, which is not much making sense, but still you just added the account number and the price part. Okay, so okay, you're calculating sum of price, right, and mean of price, right? You're getting this cumulative information. So based on this, you can make you can understand which representative under which manager is doing pretty well, right? As you can see, Wendy is doing pretty good over here, right, with the average price of, yeah, this. Okay. So that's all from pivot table. You can explore more things around it. Let's now get into normalizing JSON. Uh, Earlier, when you did a red JSON, the fight was quite flat, right? There was no hierarchy in it. And what makes JSON pretty useful for storing unstructured information is you can have any number of hierarchies in it, right? So this is how the data looks like now. You can see you have state, short name, info, governor, right? And inside this, you have another level, countries, and you have more information around it. See, countries more, and then again you have state, short name, then you again have countries. So as you can see, there are like multiple level of information. So for that, you pandas IO library is there, which is to deal with all this stuff. So for JSON, you look from pandas IO JSON, and you can use the function JSON normalize. If you directly do JSON normalize and data, as you can see here, it is trying to do its best. Counties that you see here, okay, it will put all of them in the same row. It does not understand how to break it up, but rest of the stuff it is able to do. So we have to tell it that, you know, it has to deal with counties. Okay, so data and counties, and you have to tell here in, okay, the state information. Inside state information you have info, right? Inside info you have governor, right? That is what you have to tell, and you have to maintain the hierarchy over here. Okay, counties, okay, then state, info, governor, right? You have the level of information this way. Okay, this is name, this is population. So because you have mentioned counties over here, it is breaking it up, and you can see from the unstructured format of data, it has now converted into things like this. Okay, so you can see the state, the level here. This is first level, counties, right? If I, right, this was first level, and in case if I don't mention this, right, you can see here it is breaking down the counties part, right? It understands now that it has to break it up, it has converted. We want the rest of the information as well, right? So you have state, and in case I don't give this part, right, you can see state information, but we want inside state we have this info, and inside info we have governor, right? So that is why we are doing it like this. Inside state we have info, and inside info we have governor. So that is what it brings to the table. That's all what you do with semi-structured data when you like the book that you have. And remember to mark it up. It's pretty useful, and use this very often. Be it weather data, be it stock data, time series is a small important piece of information that you have, and you really want to have that so that you can understand what has happened between a phase of time. Okay, that is where time series get into action. So we have a data like this. So this is customer churn data. So this data had a couple of columns, which is time. Okay, so you can mention them, parse date, and you can mention these column names. Okay, this will be like time information. On doing so, your data frame will be configuring these columns with this data type, date time. Okay, and there are certain advantages if the column data type is date time. Okay, because we get more powerful ability to filter certain data. Let's see what it does. Okay, the first thing that we do is we can set index to that. If you want to access data in a data frame from date perspective, we have to set index first. Keep this in mind. Once you do this, and of course you're doing in places so that the current data frame is altered, you can do things like this. This is the first date, this is the second day. You want all the transactions that happen between this. And this is not possible if you don't treat this as date time object, because it will not understand. Your data might be in different order. Okay, it is not just string match here. Okay, because some of the transaction between these dates can come in later part. It will not take care of it. Whereas if you consider them as date time, it will get all the rows which is in this range, and for that you have to make sure you do set index. Okay. One more thing. So if you directly load the data, as you can see, it is treating it as an object over here, right? Of course, you can use the previous technique, parse states, and treat this as a date time. And sometimes if it's not that way, okay. So what you can do is you can use the function pd2 date time to convert this date time object into date time string into date time object. Okay, so that's all from Pandas. That is, this is, if you understand all the topics that we have covered here, it is good enough to start with machine learning. You will do all needful data analysis using this. Okay, and once you are done with the data wrangling using it, you can subject the data to visualization tools like Matplotlib, like Tableau, like Plotly, Seaborn, to get some visualization of it. But this is good enough for getting started with machine learning. Thank you guys. See you in the next video.